freshly brewed and ready to go. You're listening to Espression with Ishita and Alejandro.
No script, no filters, just two friends and a lot of caffeine.
Welcome to today's conversation. Welcome to the debut of Passionary, a special series within the Espression world where we peel back the layers of what drives people to do what they do.
I'm joined by my co-host Ishita, and today we are diving deep, literally.
Our first guest is Angélica Aguirre, a PhD researcher at the University of Exeter who is currently navigating the complex waters of marine biology.
From the coastline of Lima to the laps of Devon, Angélica is investigating the next generation of biopolymers. We often hear that bio means better, but is it really that simple? Today we're talking about the chemistry of our oceans, the secret life of Pacific oysters, and why the solution to plastic pollution might actually start in your kitchen.
So let's dial it in.
So welcome to episode 1 of Passionary, the series where we talk to someone about their passion, about what they're doing to achieve that passion. For this first episode of Passionary, we have a guest, Angélica Aguirre, a PhD marine researcher at the University of Exeter. I'm going to let her introduce herself in a bit, but just to say that she has been a really good friend and really glad to have you here, Angie.
Hello Ishita, hello Ale. Thank you so much for having me here. I'm very happy to be here. So I'm a marine biologist. Right now I'm doing my PhD at the University of Exeter. And this is based off the next generation biopolymers in marine systems. So I want to see if they have any effects, ocean acidification in the marine seawaters. And also I'm going to test those biopolymers in the species, which is the Pacific oyster, gigas.
That's very interesting. So I think the first question that we would like to ask you is to get to know how you sort of found yourself in the field of marine biology. What was the moment that made you think I need to go deeper into exploring this topic?
It's because I was born and raised in Lima. So Lima is the capital city of Peru, and Lima is by the sea. So I have always been in contact with the sea, with nature, and I think that it became like a passion to me to discover what's going on in the world. And then when I was doing my undergrad degree, there was a proposal to find pollutions, in the topic of pollution, on marine pollution. And no one liked pollution at the moment because it was quite dirty. But I really enjoyed the class, so I talked to my supervisor. And in that sense, my supervisor is a great doctor. She is from the Institute of the Sea in Peru, and she guided me and she taught me how to evaluate microplastics in different areas. And that's how I really wanted to do this PhD, because I mainly focus on the problem and not the solution, and this PhD focuses on the solution rather than the problem.
And what exactly is the goal of your investigation? What are you looking for? What are you working with as well?
So we're working with colleagues. It's a startup called Materium. So they are developing different recipes about bioplastics. In this case, the next generation bioplastics, because we have 3 generations. So the first generation of bioplastics are the ones that we commonly use. One is PLA, polylactic acid. And maybe if you go to any store, you can see those plastic bags that are biodegradable, but only compostable. So this is mainly PLA, and researchers have discovered that they is mainly made of potato starch sometimes. So they use the land. So they then create another generation, the second generation. And they thought that it was better than the first generation. However, we compete with the food with them, with the bioplastics. And then they say no, we need to create another generation, which is the third generation bioplastics. And the third generation bioplastics is the one that we produce, for example, the organic waste. So Materium, what it does is they create different recipes according to the region. In this case, the UK, we have a lot of potatoes because they love potatoes. They have a lot of peels of potatoes. Mm-hmm. So they create a recipe for new bioplastics according to what's the organic waste that we produce. And also seaweed. It's like the UK has plenty of seaweed. So there's like one bioplastic that is made of agar base. And yeah, I'm working with them. So they give me like the recipe. I develop the recipe in the lab and I test them if they are like environmentally safe.
Specifically with the third generation of bioplastics.
Exactly.
Because the thing with bioplastics, I would, someone who doesn't really know much about the topic, I hear bioplastic and I think that the problem of plastics, especially with pollution, is solved. Is that true? Like, why are there generations of bioplastics, and why is it better to use a material waste over something like PLA? And what actually is PLA? Does it have to do with plants? What is bio about that?
So right now there's like ambiguity of the term bioplastics. So according to the European plastics, they refer bioplastic is any material that can be bio-based, biodegradable, or with both features. So not all the bioplastics can biodegrade. For example, PLA takes almost like 6 years to biodegrade. Sometimes they are more compostable than biodegradable in different circumstances. So that's why they create the third generation bioplastics to also align to the principles of circular economy, because we want to reuse what we are doing right now. So it's like the waste, to reuse the waste and add value to that waste, and we can use it. And also it's like a new alternative to a petroleum-based plastics, which is like a great problem right now.
And you say circular-based economy. What does that mean? How is it a circle?
So right now, the normal like economy is very linear. So it's like you consume and then you produce the waste, and that's it. That's the end. It's like consumption and then waste directly. And it's what we have been doing with the normal plastics, the petroleum-based plastics. However, in the circular economy one, we want to add value to that waste, so it can again create like a loop, like a small loop, and we can reuse it. And then when it biodegrades, it can be also like very good for different aspects. For example, for agriculture. So also you can have like more value and more value to different parts.
I think all of that, like listening to it, it sounds pretty good. It sounds like, okay, so we have a solution here, and why don't we just all do that? But I know that your research, it focuses on the impact of bioplastics in the ocean. And there is a narrative out there that if we just switch to bioplastics, nature will take care of the rest. But your research seems to challenge that pretty directly. What did you actually find in your research?
So we want to see if this new alternative is sustainable. So if we see the sustainability, we have 3 pillars. We have the social, the economic, and the environmental part. And we focus more on the marine areas you mentioned before, because we want to see if when they biodegrade, so when bioplastics biodegrade, they can release like 3 elements, which are CO2, water, and methane. And I don't know if you have, but for example, the CO2, when there's like an increase of CO2 in the seawater, we call it this effect as ocean acidification, because the pH decreased, and it affects like different calcifying species. So it's like the species that create the shells, for example, oysters, mussels, corals. So of the acidity of these, for example, of acidity due to the CO2. So in this opportunity, what I'm doing during my PhD is that I'm testing the bioplastics to see if they produce like a great amount of CO2 and if they affect the organic chemistry of the seawater.
And is there a specific reason why you chose to study the effect on, from what you've told us about your research, from sort of the creatures in the ocean which have this calcium carbonate shell. So why did you choose to study them particularly? And does that indicate what's happening in the water as well?
Yes, so I'm using a Pacific oyster larvae. So Pacific oyster larvae are very important because it's highly commercially important, not only in the UK but worldwide. It's like there's a lot of consumption of this species. And so when they are like very small, they're like larvae. They have like this form of D shape, and they develop the shell. So, for example, if there's like a great amount of CO2 and there's like a decrease of pH, the development of the shell is going to be reduced. So they're not going to be developed very well, and it also affects like the whole chemistry of the seawater, and then we're going to be affected as well in the future, because it affects like the dynamic of the marine waters.
So basically, the
Right.
oysters are a really good test ground for measuring that ocean acidification.
Exactly.
You said, and
Yes,
yeah, and
ocean acidification.
you say that it's a drop in pH, right? So so it becomes more acid, right? So lower pH,
Yes,
more acid.
it's like more hydrogen. Yeah.
What would be the consequences of that drop practically for the ocean life from what you can?
So, for example, naturally we have like several buffers in the ocean. So it's like buffers are the ones who maintains the ocean in control. But when there's like an increase of CO2, this balance is like it's like super past the limit of the buffers. So all the ocean is going to be highly affected, especially these species which are very sensitive to the carbonic chemistry of the seawater. So we have the corals. I don't know if you have heard of the coral reefs in Australia as well.
Really important,
They
I
have been
think.
bleaching. They have been bleaching. So this is due to the ocean acidification as well, and that's why we are testing on larvae, on oyster larvae.
So what are these buffers that you mentioned? Can you explain that a little bit?
Okay, so when there's like more CO2 in the water, so it creates carbonic acid. So we have these bicarbonate ions and carbonate ions, which are like alkaline, which act as a buffer in the ocean. However, when there's like an increased amount of the CO2, there's going to be an increase in the hydrogen, which creates like the decrease of the pH. So it's like when we have more hydrogen, the pH is going to be more acidic. So there's going to be no like calcium carbonate. There's going to be a lack of calcium carbonate, and the calcium carbonate are the element that carbonated species use to develop their shells.
And basically, what you're saying is that these plastics, when they biodegrade, they, as a byproduct of their degradation, they
Yes.
contribute to a higher
To the
acid.
acidification.
Yes,
Exactly.
a lower pH, right? Which then
Lower
affects
pH.
everything.
Yeah.
So
Yes, more acidic.
because that's the thing. Usually, when I think bioplastic, I think, as Ishita said, I think, oh, the problem's solved. We found an alternative that is better than regular plastics. But what you're saying is that might not be the case. I think, right? Is that
Exactly.
okay? So, do you think that the concept of bioplastics from the outside or biodegradable plastic has become more of a marketing misleading term?
Yes. So I think people are skeptical about the term bioplastics because sometimes we see that as greenwashing. And I totally agree with that because sometimes companies like try to like the marketing in different areas put like bioplastics as the only solution to plastic pollution, but sometimes that's not the case. We need to see if they have like any effect on the environmental areas as well. So that's why I'm doing this PhD. I'm doing this PhD not to see like if bioplastics, not to say that bioplastics are super wrong, just to give like some advice in how to do bioplastic properly, so it can like have like a small damage to the environment in comparison to the petroleum-based plastics.
And have you?
That's really...
What are the main pointers that you would say? Like, is there a difference between bioplastics in terms of their impact? I mean, you've said first generation, second generation, third generation. Does that also relate to lower impact? Because you said you're studying third generation, right?
I'm sorry, the third generation, yes, because they have noticed when they have like the first and the second, they have noticed that we compete with them in, for example, for the food. So they use like a lot of land of use instead of for producing our food. is for producing just bioplastics.
Oh, okay.
And also they don't biodegrade completely sometimes. And what can they do? They can release like as much CO2 as the normal plastic. So that's why I'm trying to see if this new generation is going to be more sustainable than the previous ones. If not, I think we need to do some improvements in the development of the bioplastics.
Yeah. So what you're saying is that the kind of bioplastics that you're studying are, would you say it's like the best we've got out there in terms of bioplastics right now?
So right now we're testing them to see if they have like any effects. So I cannot say the results yet because I need to put before saying it. But yes, we are trying to test them to see if they have like any effects on the chemistry, on the carbonic chemistry of the seawater. Yes.
Well, that's quite interesting. I mean, I buy like these compostable bags, you know, and it's all green and it has all these symbols on it, and I think that, oh well, like I'm being so sustainable and you know, the damage is like completely reversed. But what you've explained so far and from your research, it seems like there's so much more that needs to be studied, and there's so much more awareness that needs to be generated before we blindly sort of accept anything as a solution.
Yes.
And there's also the whole research aspect of it, of always continuing to find new ways of solving it. And quite like the concept of the circular economy. Well, in this case, because it's the UK, I think you said potatoes and seaweed, right? But I would imagine that in other places you would also find plastics made out of other materials.
Yes.
Am I right?
Yes. For example, Materium was also working in the Galapagos Islands, and they developed different recipes. For example, they have like a lot of seafood waste, so they have used like this waste to produce more bioplastics. And also I'm doing, for example, in South America, in the part of Argentina, they consume like a lot of mate. So they are trying to develop like a base of mate as well, of mate waste. And it's very interesting. The material is very nice. So they develop like different, not also like bioplastics that are similar to a plastic bags, but also like different types of elements. I don't know, Tupperware as well. But they're still in the process of development. So it's like a web page, which is very free for all of you. And you can make it at home as well and try.
Okay, you can make plastics at home.
Yes, you can make plastic at home. It's
this at
simple.
home. Okay.
Yes.
Wow.
What's the website?
It's like cooking. So it's called materium.com.
Okay.
It's like Materiom. And if you have any feedback for them, also they are very open to receive feedback, which is also nice. And yes, I highly recommend it. You can do it at home.
That's cool.
Try to replace the normal plastic to a sustainable plastic.
So how difficult is that process? Is it quite quick, or does it take some time and patience? What is it like?
So it depends on the recipe. For example, we have very simple recipes which only takes like 5 minutes. But there are like other recipes which take like 2 hours sometimes. But depends in which one do you want to start with. So you can select, and also you can add some dyes to have like different bioplastics from different colors as well. So yeah, I highly recommend like to do it at home and have a try.
Wow, so it is like cooking.
Yeah, it's like cooking.
Okay.
It's like doing some desserts at home. It's like baking as well. You can bake them. I have some bioplastics, some beautiful plastics. Yeah, it's like in the lab I have like molds, and it's not for cooking, it's for preparing bioplastics. But all my colleagues think that I cook all the time in the lab.
Do you make them in shapes
quite
like
exciting.
Christmas trees?
Yes, so I have
and
like
stars
some square sheets. I have like it's like the normal molds. So I have like these square sheets bioplastics, and then I have to create micro bioplastics according to my original shape, or square sheets bioplastics. Yeah, according to my experiments, I just like try to change the shape of the bioplastic.
Okay, that's really cool. I'm definitely gonna have to try that out.
Yeah, go.
What I'm doing this weekend.
Yeah, exactly. Baking some bioplastics.
Yes, with your family as well.
That's really fascinating.
Right. Ishita, what do you say if we move to a break?
I think that sounds like a perfect idea.
Right. So, Angélica, welcome to our break. So the breaks are just a good way of breaking the flow of the conversation. And also in this case, we adapted the breaks from the regular Espression series to something a little bit more personal for people to get to know you better. So this break is called Extra Shot, a quick burst of energy dropped into today's episode. And it's basically a rapid fire round of light personal questions. So you get to, it's either choosing or just talking about the question or the topic that I'm going to ask. And just quickly, just for people to get to know you better. Are you ready?
Mm-hmm. Yes, of course.
Okay. So, in true Espression fashion, this is something that we're probably going to ask everyone in this series, but if I take you to a cafe right now, what would be your order?
Chai latte.
Okay.
Ooh.
And would you eat something? Or just a chai?
Will you eat? I think I will eat something sweet for cafe, to be honest. It's because I don't drink coffee.
Okay.
It makes me like...
What are you doing in this podcast? I'm just kidding.
It makes me very anxious. So I really like coffee, but I try to avoid like drinking coffee because it makes me very anxious. It makes me very
fair.
It makes me anxious too, but I still drink it. I can't live without it.
So yeah, I will choose like, I prefer like tea or like flavored tea as well. I love like fruity tea. With
spicy tea in this case.
Yeah, something warm as well.
Good. Second question. If you weren't a marine biologist, what would you be?
An archaeologist.
Wow, okay. What do you like about it?
I love like discovering things and also like history behind them. So it's not only like an object, but it's like it reflects like all the history behind. So I really want to
look back
explore
into our history.
Look back and to discover is like what's the meaning of this item or what's the meaning of this person, why is him or she in this position. It's like it's very interesting.
So you seem to like history, you seem to like understanding where things come from. Yeah, true science passion.
Yeah. Archaeology is very detailed, so you need to be very perseverant and also very patient when you're like trying to clean all the items. So I think it fits for me.
Cool. Number 3, and this is going to be kind of a funny one because you're in the UK right now, and the UK isn't really known for being the best place for food. So, what is the worst food you've tried in the UK?
Oh, wow. I mean,
first thing that comes to mind.
Oh wow, that's a tricky one. I mean, what I love about the UK are like the desserts.
Okay, then I'll flip it. What is the best food or something that you thought would not be as nice, but you actually kind of enjoy?
Oh yes, so I have the answer. It's going to be, so we have like the imperial, like the Wetherspoons pubs here.
Oh, the Wetherspoons pubs, yeah.
So with a friend called Kabir, I think you know him. So we went to a pub, and he recommended me this Indian dish. It's like it is curry, which was very nice, and it was like the best one in the UK. But surprisingly, it was from Wetherspoon, which is like very cheap and commonly known.
Wow!
And we were highly surprised about it, and we were like, "Oh wow, it's very nice." And he was telling me, "Yes, it's very nice to have a try." And I mean, I trust him because he knows how to cook, and I really enjoyed the meal as well.
Wow, Indian food at Wetherspoons.
Yeah, exactly, and it was like unexpected because we thought that it was like it's going to be very bad, but indeed it came like decent, very decent.
Yeah, that's good.
So next up, what is your favorite ocean creature? Someone who loves the ocean, clearly.
So I have 2 in mind. I love the orcas. I love penguins.
Ooh, penguins are cute, yeah. Mm-hmm.
Yes, penguins are cute, but I also love the orcas. I love because they have like this maternity behavior, and they take care of their family, and the leader is the female one. So it's the one who guides all the family, all the group of orcas. So I think I love the bond between the orcas. And I also love the penguins because also they are very charismatic. But they can like dive or swim, and it's very impressive how they can swim and survive. And also they can be like in different altitudes. So you can find like the Humboldt penguin, for example, which is close to the Ecuador. And you can have like other types of penguins, which are mostly in Antarctica. And I think they are very impressive.
Oh, I instantly want to be friends with all of them now.
Well. You're friends with all of them, yeah, definitely. One last question. How does your mom explain what you do?
My mom, she's just proud.
Okay.
I think she just tell everyone that I'm doing some research about how to find a solution to plastic pollution. Mm-hmm. And then I'm a biologist and I love the sea. I think that's how
pretty apt description.
She tells me
yeah, it's always hard to get moms to understand exactly what you do, especially when it's that deep.
It's true.
Yeah.
Pun intended.
You're like, no, mom, not that.
No, it's sweet. She was very happy.
Oh, that's sweet.
Okay, so those were all the questions for this break, Angie. Thank you so much. And this was Extra Shot. Quick burst of energy dropped into the episode. So, yeah. We will be back with Angélica.
Welcome back to Passionary after that refreshing break. We're now going to dive a bit deeper into the science of what you have been studying, Angélica. We're going to dive deeper into sort of the mechanisms, some results that were unexpected, and what they mean for the planet. So the first question would be, can you walk us through how bioplastics break down in seawater and how it changes the water?
Okay, so you can analyze the bioplastics. So you have like different standards to develop different experiments. And one of the standards is the ISO. So we use the control, which is called the positive control, which is like cellulose. And when you see that the cellulose is totally disappearing from the seawater, is when your experiment needs to stop. So you just measuring, for example, I was taking different days of my experiment, and according to the days I was measuring like the DIC, the TA, which is like dissolved inorganic carbon, the total alkalinity, different like physicochemical parameters like the pH, the dissolved oxygen, and also the temperature, to see if they have like any effects on the water. So that's how like I test the bioplastics. I'm so sorry, I cannot say like my results for my complete experiment until it's completely published, but yes.
Okay. And you mentioned that the cellulose, when it starts dropping, that's when you need to stop further testing. Is that true?
Yes. So according to the ISO, is when you see that the cellulose is completely biodegradable, or it's disappearing because the cellulose is quite white, it's like a filter. When you see like it's disappearing and it's disintegrating, it's when you need to stop your experiment. And yes, and also you can measure it like weighting the bioplastic. So it's like you weight at the beginning, of the experiment, and then at the end of the experiment to see the percentage of biomass loss of this new material.
Okay. And why is it that you need to stop when the cellulose levels start going down?
Okay, so in these standards, so you have like the positive control. In this case, is the cellulose, because scientists know at what time the cellulose is going to stop, and they know that the cellulose is going to biodegrade completely. So there's only like our results that we know that this material is going to completely biodegrade in comparison to the materials I'm going to test. I don't know if they biodegrade, and if they do, they can release like as much like CO2 as the normal plastics. So we need like a base in this case is the cellulose. And then we can compare the ones that I'm going to test.
Okay.
Now, another question that I was just thinking about relating to ocean acidification, and just this concept of the plastic still has an impact in the seawater in the areas. Does that relate in some way or form to climate change? Does that contribute? Is that also a link?
Yes. So there's like an interesting paper from Villarrubia, and she mentioned that plastic pollution has an effect in different systems. So it's like one of them is the climate change as well, the use of land. So we need to see, I think we mostly focus on plastic pollution, but at the end of the plastic pollution, so we don't focus on the beginning of the life cycle of it. So from the beginning of its production, for example, when they manufacture this material, they have like a lot of CO2 into the ocean and also into the environment, and it can affect like different systems in Earth. But also we can see like when it is like the end of life of this material, it can enter the ocean and it can affect different species as well as the human being. So yes, of course the plastic is affecting everywhere because it's very flexible. It can be like from different shapes, different colors, and different materials as well. And we need to see it from its production till the end of life to see how it affects.
And also, is the damage concentrated in the areas where the plastics are disposed? Like, for example, like the UK, you're in the UK, you're focusing on the effects around the UK. But how does that, is the damage sort of, if the plastics are thrown into the ocean on UK coasts, does it stay on the UK coasts, or does it also have an impact on the entire ocean, the world,
yes,
the oceans
in
of the world?
ocean. Yes, due to the ocean currents. So there's one example in the Pacific Ocean. So it's like moving from the UK to the Pacific one. We have this plastic patch. I don't know if you have heard of it.
Yeah.
So we have in the middle of the Pacific Ocean a plastic patch, and it comes due to the mainland. It's because we have like a lot of
plastic patch.
Well, So in the middle of the Pacific Ocean, we have a plastic patch. So it's like an island made of plastic.
Wow, okay.
It's because due to all of our waste that we produce, and sometimes people just dispose on the coast. So the ocean currents come and wash the coast and leads to this center in the Pacific Ocean, which is like the plastic patch. And it's massive. It's like the size of an island. So it's a huge problem. Some currents is like the ones that move the plastics around the ocean, and it can affect different species, also from the bottom to the top of the sea as well. Not only superficial, but also like in the deep of the sea.
Mm-hmm. Does that have to, is there also a relation between bioplastics and microplastics? What is your take on microplastics as well? Because I think as someone who also is sort of outside this world, we hear about these little small plastic bits that affect life in the sea and us as humans. How does that work with bioplastics? Is there also a concern there?
Mm-hmm. So microplastics are, like in the majority, are petroleum-based plastics that can be produced at that site, which are called in microbits, or that can be produced due to from a larger plastic. So the normal plastic sometimes breaks down in the ocean due to several effects. For example, the irradiation, the UV radiation can also break down the plastic and produce microplastics. Also, when it enters the ocean, the waves, the strength of the waves also can break down the normal plastic, producing microplastics. And they have because they are like small particles, they can be found in different places. And in the sense of bioplastics, we are now testing if they can break down as like the normal plastic as well. And that's why I'm also making them in different sizes and also making microbioplastics to test them.
Microbioplastics? What do you mean by
So
that?
it's just like breaking them down. So you have like the big
Okay.
bioplastics. It's like breaking them down in small particles that can be like a size less than 5 millimeters to see if they have like any effects and the fate and behavior of them in the ocean.
Wow.
It seems like the whole microplastics thing, it's in any ways like really scary. Like every time I read about microplastics in the news or anything, it's like, oh, like you're finding it in like food, you're finding it in like human bodies, and it's quite scary. And so you're saying that we don't know much about sort of the, like you mentioned, microbioplastics. Like we don't know much about that yet.
No, it's quite new right now. All the world of bioplastics. Also, the ambiguity of the term is due to the lack of knowledge behind bioplastics. So that's why I'm also doing this PhD to have like more research about this new area. So right now we have like a good baseline of microplastics and plastic pollution in general, but we still need to do more research on bioplastics.
So someone who doesn't really know much about plastics, who gets like a regular consumer, would you say that they're better bioplastics than others that you, like as someone, as a consumer, would be able to use?
So as a consumer, I would recommend to add value of what you have. For example, I don't know, if you have a backpack with you, if you're a student and you use normally like a backpack or a bag and you go shopping, it's like try to add value to those things that you already have. For example, if you have a backpack, yes, use your backpack for normally like buying things like, I don't know, in the stores and everything. And also if you add value to the things that you already have, I think it's less consumism. So it's also less production of plastic, and then it's less production of plastic pollution. So I would recommend to add the value to things that you already have. And if you just like, I think like the intention of producing plastic was to make like life more easy for people, which is a good idea.
Yeah.
But sometimes good ideas
Go too
have
far.
consequences. Exactly. Like I think in Spanish we have like this phrase which is like a path to hell is made with good intention. So it's like sometimes we have like a good intention. It's like the path to hell.
The path to hell starts with a good intention.
Good intentions.
Okay.
Exactly. So it's like the same with plastic. So we had this good intention to make like life more easy for people, and you can be like more like you can find it everywhere. Like plastic is very flexible. It can be like adaptive as well.
I was watching some ads on plastics from like the, I don't know, 50s or 60s, and they said that plastic is going to be the future. Everything is going to be plastic, and you just take it and dispose of it. We didn't even know what the consequences are going to be.
Yeah, and it started like as a good intention, but at the end, it was not that good, the consequences. So yes.
So you're saying that,
yes.
or do you think that bioplastics, because I mean you say add value, sometimes you still do need an alternative to a plastic, so that's when you say bioplastics. But what would you say about the idea of just stopping the use of plastic? Do you think that's A, feasible, and B, a good idea, or do you think that we should just eventually phase all plastics to something that is bio-based and biodegradable?
Yes. So sometimes I think it's a good idea to try to find like a new sustainable alternative. Oh, this is a tricky question, to be honest, because it's not going to be fully sustainable. Even if it's like bio-based, biodegradable, even if it has like both features. We don't know if they are using like the land to produce these new bioplastics, and also the use of land can increase more impact on different like air system processes. So try to use, I think for me it's like try to use what you have. If you already have like a plastic bag, because we all have like plastic bags, try to use it like as much as you can. It's like have try to have like longer than sometimes it's just like use and dispose. Also, if you have like containers, I don't know, like you have like these like from glass containers from yogurt or I don't know, just try to reuse it like as a Tupperware.
Is that also kind of related to the principles of circular economy, or is that more like reusing?
Exactly, it's more like reusing. It's like regenerate nature. It's like try to creating more like loops. And also like I think adding the value is essential to combat like plastic pollution in this opportunity. And if we need to buy plastics, try to use it like as much as you can. So like, try to add the value to that plastic.
Okay, yeah. So lesson for everyone there, yeah.
So it's like you say, it's like reusing what you have and what works already and sort of reducing consumption of new things that could cause more problems, which is, I think, it's like going back to the roots of reuse, reduce, recycle. It all boils down to that, I think.
Yes, so it's like not that much like recycling, but more of that like trying to
Use less, I think.
use less. Trying to use less. What do you know that is going to affect the environment later? And if you want to use like a sustainable alternative, for example, the PLA is compostable, but you need to go to a specific place to compost that PLA. Place like mainly like industry. It's like if you're conscious about that, it's like just go and deposit in like a normal in the factory that compose PLA. Just try to be more conscious about what you have at the moment and how it can be disposed at the end.
So it's kind of embedding that sense of responsibility in people to carry out the right procedures and do their part so that waste can be dealt with correctly. And I think that's a very important thing, and there's so many people around the world pushing for it, but it's just, I mean, it's a challenging thing to do as well, to make people do something that's good, because inherently, humans are going to be lazy sometimes. They're going to make mistakes, they're going to take shortcuts. But yeah, I think the more people know about it, the more people know about the actual impact of things, as you have so clearly mentioned, Angélica, the way you've explained it. I think if more people knew about it, at least they would make some bit of effort. I know that I will, because there's a lot that I didn't know. And after knowing all of this, I'm really rethinking a lot of my purchasing habits. And yeah, so that's very, very helpful, what you've shared.
Yeah, I think that's what's the important thing about research like this. It makes you reconsider what you do and how your actions affect the world. And yeah, especially with bioplastics, again, like we hear so much about it in terms of, or especially like if we're in a country that is trying to, because there's also the policy topic here of governments trying to find new ways of being more sustainable. And so there's a lot of marketing and politics around this idea of, now we're going to move to this because this is what's sustainable. But we don't really know exactly where that's going to lead. Like if we had actually believed the promises of plastic 50 or 60 years ago, if we didn't even know what the consequences were going to be, we're still figuring out if this is the right way of making something like a material, like a material that has the properties of plastic or not. So it's also really important to always keep innovating and researching and trying to find the truth behind everything. So, yeah.
Yes, that's totally true.
Okay.
Yeah.
So now we are going to go on a break for our last segment in episode 1 of Passionary.
So welcome to our break. This one is called Single Origin. This is a segment where we return to the origin, where it all started. So we've been deep in the science, but let's go back to the grounds, pun intended, for a moment. Let's go back to the start. I'm going to ask you to go back, not to the beginning of your career but the moment in your life that made you who you are in this field. It can be a childhood memory, teacher's words, a discovery. When did you know what your passion was?
Oh, wow, that's a difficult one. I think it was because I like competing in general. So my father, he's like a chemist engineering, and and I really wanted to like fight with him in a sense. Like I really wanted to do science because I was very good at science. Mm-hmm. I was like at school, I won like different prizes due to my scientific developments and scientific like experiments. But I didn't want to be like a chemist. So I chose biology because biology is very nice, it's very sweet. And I really love to be like out of my comfort zone. And I think marine biology, for me at least, is being out of my comfort zone because it's quite different. Sometimes it's quite risky because you go to different places and explore and also like try to discover and research about it. So I'm really passionate about it. You also need to be very good at like having and at managing your time and also your resources. And yeah, I think that's why I chose marine biology. Also like to compete with my father and also to to do something out of my comfort zone.
And what would you say to someone who is also interested in science and who says, "Oh, I want to be a marine biologist. I want to go out there, explore the world." Someone who's younger, I don't know, maybe 12 to 17 years of age, and who's just looking at someone like you and being, "Oh, I would like to do what she does. I would like to contribute in that way to the world."
I will say to that person or that kid that yes, if he or she wanted, it's like go for it. It's like there's nothing that stops you, but also it's going to be like a path in you can grow in different aspects, because it's not going to be easy, because sciences sometimes we work for the art, so it's not feasible sometimes. You just need to keep working to pursue your dreams. And also I don't think it's only in sciences, maybe it's only also like in different topics, but in science you need to be very perseverant. You need to study a lot. Is constant, like it's like discovering new things all the time. So you need to love reading as well, because you need to read a lot of papers. And yes, if you like that and if you really wanted to be a marine biologist, go for it. You are going to learn new skills during that journey, which is going to make you improve in being like the best marine biologist.
That's quite inspiring, I think. It shows how hard you work to get where you are, and it's gotten you, I hope, a lot of satisfaction in life, the things you wanted to do, and it's definitely very inspiring to hear your story. And the fact that it started with your father, I mean, it all goes back to the family, and it's been quite the journey.
Yes, so it's because they wanted to be like also like an engineer or something related, or medicine. So I really wanted to do something that I really like, which is sciences, but also something that I feel fulfilled. So biosciences is very nice. It's lovely to explore and discover new things. It's like go out of the comfort zone. You not only have like the lab work, but also the field work. And well, it's very important. And you also have part of chemistry as part of biosciences. So
yeah, so now I can talk with your dad about, well, now it's your domain as well.
No, he loves he is in love with chemistry.
Okay. Well, anyways, Angélica, thank you for this break. Single origin, return to the origin, where it all started. And yeah, we'll be right back with the last part of our conversation with Angélica, the PhD researcher and marine biologist. We'll be right back with Espression. Okay, welcome back to the last act in this first episode of Passionary. We are here with Angélica, and now we want to move on to a view towards the future. and also talk a little bit about the systems part of it, because you said, or we talked in Act 1 about circular economy and this idea of creating systems that ultimately contribute to that loop of waste being converted into something that's useful and having value across the whole chain. So in this case, like, there's a system there, isn't there? There's a loop in the circular economy. Like, what does that actually mean in terms of what you're trying to accomplish with the research?
So I'm doing right now research in 3 different regions. So I'm doing different workshops. So I'm using this approach, which is called system thinking. So system thinking is seeing the topic or the problem that you have like as a whole. We have right now a traditional thinking, which is just cause and effect. But in the sense of system thinking is everything is interconnected.
Cause effect is, like you mentioned, Act 1, like it's a linear relationship where things are created and
like
then
a
they're disposed of.
Yes. So it's like the traditional thinking that we have right now, but in the circular economy, in system thinking approach, we see everything as a whole. So everything is interconnected, and we can, for example, think as a domino. At the end, it's going to go back to the origin. So that's the approach that I'm using in the last chapter of my PhD, and I visualize it using causal loop diagrams. So causal loop diagrams, we can see the different interactions within the factors, and to develop these causal loop diagrams, I'm doing several workshops, not only in the UK but also in South America and in the Galapagos Islands. So I have a framing question to ask what they think about bioplastics, and I ask different stakeholders from the industry, NGOs, the local community, the academia, what they think about bioplastics, and they give me the feedback about it. And we create these causal loop diagrams to have policy outcomes and also recommendations about the topic of bioplastic adaptation in 3 different regions.
So you say the UK, South America, and Galapagos, right? Well, which is also an island in Ecuador, close to Ecuador, right?
Yes, so we separate South America to the Galapagos Islands. So islands are like the ideal scenario for circular economy because they don't depend, like they don't belong to the mainland, to the continent, and because they are quite close, there's like a flow of materials, also of different species and of different areas in that small space. Is quite limited. It not only has like limitation of the borders, like physical borders, but also in the flow of the materials. So incorporating like the circular economy in islands is very essential. And also there's like a PhD previous to mine, and she developed like the circular economy about plastic pollution in the island. And yes, she's doing like work. She's working right now in the Galapagos Islands.
Wow. Okay.
So that's why we also had like a workshop there. And Materium, which I mentioned before, they have adapted a recipe for bioplastics, and they are trying to adapt the bioplastic inside the island to see if it works or not, and to take some feedback from them. So that's why I'm doing the workshops in different regions due to the adaptability of bioplastics. So we have the island, which is like an ideal scenario for circular economy. We have like the South American one, which is still developing new policies about circular economy and about bioplastics. And also another scenario, which is the UK, when they are more developed about the adoption of bioplastics and also like new rules and policies about how to avoid plastic pollution and how to incorporate circular economy.
So you mentioned that you've had these workshops in all these different locations. Can you describe what you do in these workshops, essentially?
Yes, of course. So we use a group model building. So I invite different stakeholders that have knowledge about plastic pollution or bioplastics. And I invite them via email or in person. So they come and they need to fill a form from the University of Exeter that they are accepting being part of the workshop. Then I explain them first about what is system thinking, what's bioplastics, like the production of bioplastics in Europe and the different types of bioplastics. And then I ask them the framing question, and they need to only use one word to relate to that framing question. And after they add the word in a paper, in a post-it, they need to organize the factors. So these words are the factors in the order of priority. So which one has like the most priority and which one has the least priority. Then we use the connect the circle exercise, in which in a flip chart I just draw a circle and they need to put the factors in order but clockwise direction. And after that they need to find the interaction between the factors. For example, I don't know, it's like more deaths is going to lead to decrease of the population. So for example, like that, we have like deaths, population and birds. So it's like more deaths is going to be less population, and then more birds is going to be more population. So it's like they need to write the relationship.
So you're trying to get them to understand the system and the circle within that system.
Yes, so it's like they need to try to identify, it's like which one has like an effect on the other factor. For example, I mean, we have like single-use plastic. I don't know, single-use plastic is going to affect the environment. So they draw like a line. So it's plastic, environment. And then they need to identify is this positive or negative. So we have two factors, the arrow, and then need to add the plus when both of the factors goes the same direction. For example, if we have more plastics, so it's going to be more pollution. So both of them goes like the same direction. Instead of if we have more plastics, we're going to have less water supply, for example. So it's like one goes like one direction and the other one goes a different direction.
So basically how everything is connected and how one thing affects so many other things that we don't know. Which seems to be a recurring theme here with how plastic
and
affects
then we create
us.
And then we create like different scenarios and loops, and according to those loops we like give advice on policies, and we have some recommendations.
Speaking of that difference in policies, or I mean also kind of I think it relates as well to the people, because I mean these workshops are with groups of people, right? I wouldn't imagine they're really, really large groups of people. But you also mentioned in Act 1 about pollution, and there's also like you're in two regions, right? You're in three: Peru, South America, and Galapagos. But what would you say would be different about how the introduction of bioplastics would play out in each region? So both in terms of policies, infrastructure, and also like culture, like what kind of differences have you seen in terms of like establishing a policy that actively works with bioplastics and reaches everyone to make them conscious of what we've been talking about, like impact, all of these factors that also affect what we do and what in our lives.
So I have seen during the workshops that in the Galapagos Islands they are more open about new sustainable solutions, because they really want to get rid of plastic pollution. And in the contrary, we have South America. They are more skeptical about bioplastics. They think that it's greenwashing, and they have this mentality that this is not going to work. Also, sometimes we have different types of bioplastic. In South America, I talk, like according to my country, for example, we buy a lot of stuff, like heavy stuff. For example, potatoes. We also like eat plenty of potatoes. And sometimes when we use biodegradable plastic, it doesn't hold the amount of potatoes that we buy, and it breaks down very easily.
The max weight.
So, exactly. So it's like they're more skeptical about bioplastics. They don't think it's going to work, and yeah, so the adoption of bioplastics, in my perspective, is going to be more slow in South America, and in the UK, they're doing it well. They are more positive about it. They are still skeptical, but they are like between like the different regions. So we have like the more skeptical, which are like the South American one. Then we have the UK one, which is like, yes, it's like more open to adapt it, but at the same time it's skeptical. And the Galapagos one, which they are very open to accept any alternative that can help to reduce plastic waste in the area.
And what about infrastructure? Like, is there, because you said that some plastics need to be processed in a certain way. So do you think that that's also important, like looking towards the future, if there's certain processes that have to be made, does the UK have an advantage in that case, or something like the Galapagos Islands, where people are actually also more conscious and more, and I would imagine it's also because they see it every day in their environment. I mean, who holds the advantage here? Like, what gives you a better advantage? Policy, like forcing people to adopt something, or just in general the community sort of contributing to reduce the effect?
I think the policies, because without the policies, there's no change of behavior of the people. So I don't know if in your countries it happens, but in our country we have like a law to ban single-use plastic, and it helped to reduce the use of petroleum-based plastics, and it also like changed the behavior. So people need to carry their own bags when they go shopping, and also they have this law here in the UK as well, and you can see people that go with their trolleys and just buy some stuff. And we need like the international national pressure on not only on the people but also on the big companies that produce plastics, because those are the ones that are affecting the environment directly.
And another like question that I have coming from, because I have a humanities background, mainly in psychology. So do you think that these differences that you've seen across the three regions that you are exploring, is it also due to the experiences of people with plastics and bioplastics? Is one region more affected by, say, the damages of if anything, or is it more similar throughout? And is sort of what I'm asking are these different attitudes coming from a personal experience as well, or is it just the infrastructure and policies?
I think also of course it has like the human's perspective. We have the Galapagos scenario in which they depend most of the tourism, and they have seen that the plastic has affected this national park, the Galapagos Park. Some people are not attracted to Galapagos because it's quite contaminated, and it affects the tourism. This is one they live for. They live for the tourism in Galapagos, and that's why they have this more easily change of behavior, and they are more up like to accept more sustainable solutions. They want to have like their own production of bioplastics because they really want to ban plastics in their area. They're more conscious about it. In our case, I think South American one depends on the country as well. We have different behavior according to the country. Sometimes in the case of my country, I think you need to have like a deep study on how people behave. So I think it's like not only policy but also like the part of humanity and social aspect. So they both need to be together to get rid of this problem, because we are quite lazy sometimes, and because we don't have like the correct infrastructure to the end of life plastics and the end of life bioplastics as well. So sometimes people they don't segregate the waste. They just put everything in one bag, and then it goes to the ocean directly, or it goes to the land. So yes, and in the UK is more developed. People are more skeptical. I think they have more options in the sense of what they can choose or what they can choose, what they can import as well, because the UK usually import all of the materials, all of the, for example, the organics, the fruits and everything. And the politics of the UK in the terms of plastics, they are based on the European politics, so they have incorporated that into the UK. Yeah, so that's the difference between the sectors.
So it's like the people's behavior and attitude kind of connects back to policy again. Would you say that?
Yes, it connects back to policy. I think we need to work together, because it can only, it not only be one field, like not only policy, so it needs to be more holistic, like an holistic approach.
Yeah.
So we need more intervention in different areas. The social part is very important to, for example, if we live in a country that usually likes to contaminate, we need like a social aspect to see how can we reduce the contamination of plastics. And also it needs like to be hand by hand with policy and also the part of the research, because we need to know what to do in the part. We need like scientific background to make new policy. So I think everything is interconnected, and if we want to solve a problem, we need to see everything like system, like as a whole, which is like part of my PhD. So it's not only like policy, but also like the social aspect, the environmental one, and the economic one.
So on that note, if you were talking to someone who was building a government policy on bioplastics, what would be your top 3 things you have to watch out for, things to consider when writing a law that, for example, involves the use of, single-use plastics? I think there have been these laws that have completely banned the use of single-use, but what about the introduction of bioplastics? What are the main things that we need to consider when writing the legislation around them?
I think we need to consider the unknown effects of bioplastics, because right now we don't know what are the effects of bioplastics in general, so we need more research about it, and we need more funding so people can research more and find out what is the best solution to plastic pollution. So my first one is the unknown effects of these new materials. Then I will recommend them to look, of course, for the policies, for the region, but also for the infrastructure, for the end of life of the materials, because in some countries, especially in developing countries, we don't have ideal scenarios to the end of life of these materials, and also the landfills are collapsing.
So it's like we use the material, but we don't have the ability to process it.
Exactly. Yes.
Okay. Mm-hmm.
And is there any evidence that all the damage that has been caused so far? I think that's like a very hopeful question that is on everyone's minds when they hear such conversations. Can any of this damage, is there any research supporting evidence that any of this damage can be reversed? And if so, to what extent?
That's a good question.
Yeah, so according to the bioplastics, we still don't have that much of evidence. Mm-hmm. We are still in the initial part of developing more evidence to support more policy. But in terms of plastics, yes, we have plenty of evidence about how it is affecting different environmental, different earth system processes, also how it is affecting also the human being. However, we have these other factor, which are like different politics from different countries have different perspective about plastics. So I don't know if you have heard about the reunions that the political leaders had about plastics. They haven't made an agreement yet because they have different interests.
Right.
Makes sense.
According to how it's going to be about plastics. Sadly, because different countries have different interests according to plastics. We don't have an international agreement on plastics. So the national agreement is quite ideal right now. It's like every country needs
It's
to have a
fragmented.
national one. But the big countries, like the most developed countries, really need to like
Get
be
their
more
act together,
environmental aware.
work on
Yes,
some common standard.
yes, yes.
Okay, we're reaching the end of this last part of the conversation, and I want to move on to another question that is more of a personal one, just as a closer, or one of the closing questions actually. But it's what, so you come from Peru, right? And you came to the UK to do your PhD. And how has that shift changed in terms of, I mean, we've been talking about policy, government, but also society, like how people view and what people value and what they care about when they, in terms of sustainability and ecology and all of this. So how has that perspective changed? Like going from Peru, how does that work in that region? And what was your shift to the UK, which, I mean, as you've said, things differently, a little bit about these things.
So I'm mainly going to focus on Lima because Peru is quite big. It's like bigger than the UK. And I think like different regions inside Peru has like different perspective and different lifestyles as well. So I'm mainly going to compare like Lima to Exeter, if that's all right, because I have more idea of both
Lima
scenarios.
is the capital, and you are from Lima, right?
Yes, I'm from Lima. So I think in Lima, we are really attracted to what's trending right now. So we really don't care about the environmental impact. We love what is trending. We love to do like what's like, I don't know, what people are doing right now, what like this social media is telling you to do. So we get with the flow of social media. We like the influencers. Not all of us, but most in Lima, they are like, oh wow, we need to do this, like, I don't know, this cafe is very trending. Oh, let's go to this cafe. It's like this cafe is using these lovely plastic cups. Oh, it's very lovely. Let's consume like a lot of this plastic bag because it's like it's trending. And in Exeter, because it's quite like it's smaller as well. I think they're more conscious about. They're more aware about like the environmental impacts I'm seeing in all of my colleagues, in the professors as well, and the people that live here. They try to be more conscious and more aware about plastics, so they love everything that is handmade. Also, they go to Darts Farm to buy like their groceries, and I think that's
Darts
a
Farm,
big
is that like a farmer's market?
It's like a farmer's market outside Exeter, and they love going there to buy like some groceries. They try to be more sustainable. However, in the stores you can find like all the fruits are wrapped in plastic wraps, which is quite concerning, but
which I think is quite a European thing. I was also shocked.
It's very European.
Yes.
Yes, everything is it's like in packages.
Like wrapping fruits and vegetables in plastic. That was a difference.
That's very bad.
It's a bit weird.
But it's very weird, yes. But yeah, right now I'm seeing like, wow, it's like in Lima we're like more, it's like trending. I'm not going to this store, buying these clothes and polyester clothes that are not good for the environment as well.
And so what are you working on next? What are you, what is the future of your research right now?
So I'm going to continue with my experiments. I'm going to test the bioplastic in the oysters, and hopefully I can have more results, so I can publish as well my chapter 4 of my research. And I will let you know when I publish it.
For sure, we might even have you for another episode here.
Yes, of course.
I think that brings us to a nice ending to this first episode of Passionary. Angélica, we want to thank you for taking the time and talking about your passion, which is marine biology and researching about bioplastics. And you have shared some very important information today, which I think it's so important to share that, and we're so grateful that you've done that for us, and you really seem to be passionate about this topic. And we hope that you achieve everything that you want in this field.
Thank you very much to both of you. I really appreciate the time and to contact me before to have this lovely chat.
We're still nailing the format, but I think the idea behind Passionary is as well to talk about people's passion, their motivation behind why they do what they do. So one more thing, and this is a question that we're probably going to ask to every guest who comes onto this series of Espression, and it's the closing question. There's no time limit. You can answer freely, and this will be the end of the episode. And it goes back to the passion theme. So what are you doing now to achieve your passion, and where do you see yourself in 5 years?
Okay, so I'm trying to improve my skills. So it's I'm trying to improve some skills that I need to improve. I'm trying to be the best version of me, not only in the academic area, but also in different areas. Maybe trying to rectify some mistakes that I have been doing before, and also trying to be gentle to myself in this PhD journey, because it goes up and down. Sometimes it's like a roller coaster, and you really need to be very gentle to yourself and to remind you the value that you have during this journey. And I'm seeing myself in 5 years content. So I am seeing myself very content in what I have been doing all this time. I mean, right now I don't have any idea in what's going to happen in the future. I'm going to try my best in all these years, but hopefully in 5 years I'm going to be content. I'm going to be happy with what I have done and what I'm doing during that time. Yes, that's it.
That's really nice.
Just like the smooth layer crowning a perfect espresso, we've reached the crema, the rich distillation of today's talk.
We learned that bioplastic isn't a magic wand. As these materials break down, they can actually change ocean chemistry, making it harder for tiny oyster larvae to build their shells.
The real shift isn't just in the material, but in the circular economy, moving away from the use and dispose toward valuing our waste, whether that's potato peels in the UK or seaweed in the Galapagos.
As you finish your brew, remember that the most sustainable item is likely the one already in your hand. Keep your curiosity fresh, your waste low, and your passion for the planet even stronger.